Is this thing on? Can you hear me now? Verizon paid me $1 million to say that. How's everybody doing this morning? All right, that's good. We're going to talk a little bit about how to get these MFA snakes off this MFA plane. I have to keep it PG because we're recording and there may be kids here. So let's talk a little bit about bypassing multi-factor authentication, folks. By show of hands, who uses multi-factor authentication? Everybody's hand went up. That is amazing. All right. So who am I? First and foremost, I'm a father and husband. My wife tells me multiple times every single day, my son is my son. I'm not sure if that's a good thing or a bad thing, but I'm the CTO at ProCircular. We're a cybersecurity services firm headquartered here out of Coralville. Offices in Des Moines and Minneapolis as well, but heavy focus here. A few letters, a few certifications from my past. I've got about 18 years of IT experience, 10 of those are which in cybersecurity specific consulting. I'm a recovering pen tester, recovering SOC and IR analyst, recovering from cybersecurity war stories every single day. I like to golf. My scorecard does say otherwise. And the most important question of the day, bourbon with or without ice. Who's got the right answer? Doesn't matter. Bourbon is bourbon, so it's a win-win. All right, so what we're going to do here in today's session, we're going to talk a little bit about what multi-factor authentication is. It will be one of the only slides that I read because it's Microsoft's definition. We'll talk a little bit about how MFA's evolved, a little bit about the attacks. We'll demonstrate a little bit of fun data because you always have to have data in presentations today with the rise of how those have been happening over the last few years. The best part of the day is going to be our demos. I've done too many talks and hotel and conference Wi-Fi stinks, so I embedded videos. So we'll take away some quick wins on what we can do, and then most importantly, we'll talk about what's next. So what is MFA? According to Microsoft, multi-factor authentication is a security process that requires users to provide 2 or more forms of authentication for identity verification for accessing systems. Commonly and in the infancy, this was referred to as 2FA or two-factor authentication. Contrary to what MFA is, they are different. It requires more than 2, and we'll talk about that. Multi-factor authentication is something you know. Username, password, preferably you know your password. Whose password is password in here? Raise your hand. All right, we got a couple. That's good. I love it. Second, it's something you have, a key, a hardware token, your phone, access to your email address could be considered another form of authentication. And then most importantly, something you are. This is the evolution, right? Your fingerprint, your retina. Who loves staring into a screen with flashing red lights? No, I'm thinking AI is going to jump out and like the rise of the machines are going to happen at this point every single day. So why MFA? Who thinks passwords are secure? By show of hands, who reuses passwords across different websites? All right, that's good. Not really, but hey, it's a start. There's only a few hands coming up. Passwords are inherently insecure because we have to remember them, and we have 4 billion of them to remember, right? Compliance requirements. Who in here has cyber insurance? Who enjoys cyber insurance? Right? They're going to force you, right? That checkbox. The #1 question on that 75 question questionnaire is, do you have multi-factor authentication enabled? Hopefully you're answering yes and you do. Other specific regulations and compliance is going to requirement, but really this is just general cyber hygiene. And most importantly, it's layered security. Now that I have a son, it's awesome. I can start watching Disney movies again. Shrek is one of my favorite all-time movies. So every time I talk layered security, it's Shrek, right? Shrek and Donkey. It's about the layers. So more than one thing is always better than not. So evolution of MFA. Two-factor authentication was actually introduced by AT&T in 1997 There's controversy on this, but they have the first documented patent. In 2000, we had OTP or one-time passwords come out via SMS. That's that text message that would come across. Third, hardware tokens and smartphone, OTP, voice calls, things like that. That was in 2005. In 2010, push technology was introduced. Did everybody know push technology came out? That's that when you get that question of yes or no, are you trying to log in? That was available in 2010. And then really when we started to see some widespread adoption, President Obama made a Reddit post and hashtag turn on 2FA. That was in 2016. This is really when we started talking and seeing the majority of the consumer level individuals turning this on. So if we walk backwards real quick, in the 2000s, we started seeing this come out in the financial sector. So high-risk financial transactions would require more than just that username and password. You log in, you submit the wire form. Hopefully there's a dual control process there. But that's really as we started to see it outside of the government, right? Or the very, very specific sectors that needed that extra security. Really in about 2005, right, we had some additional technologies. And as it started to gain more widespread adoption in a corporate and an organizational manner, that's when we started to see the first attacks. This is when your man in the middle, your adversary in the middle attacks came out, where targeting the financial sector, because that's heavily where it was used, the attackers would inject code into a website and capture that one-time passcode. Then they'd replay it. A few years after that, push technology, although it wasn't out there, we started to see more focus on those man-in-the-middles as those smartphones were used. We do see SIM cloning. Who's familiar with SIM cloning? Talked a little bit about that last night. It's really targeted, so we don't see it, a lot of it. Now that we have incidents, people are trying to steal cryptocurrency, that's where I see most of it targeted now, more so than one-time passcode bypass. But it is out there, it is possible. And again, SIM cloning was big in, I'd say, 2012 or so in the financial industry. That's kind of where we first started to see it as well. Kind of feels like cat and mouse, right? Something comes out one year and then something else comes out, and then back and forth. And you can see I'm also a Tom and Jerry fan. Anybody else Tom and Jerry fans? Gotta love it, right? This is what this looks like. This is this is from Okta. This is from their annual identity report, and nobody can see this because I can barely see it. But you got the different colors. 2020 there is in blue. This is a chart of multi-factor authentication bypass attacks by the day, January to December. Purple or pink, depending on how that hue colors comes up back in the back there, is in 2021. And then this last one, because they haven't released a new one yet, is 2022, and that's green. And of course, the report was released June, is when that stops. It falls off, so we don't have data from there. Does anybody have an idea of why the big spike, specifically from the green? You can see as it was adopted, the attacks started to get there as well, right? Again, that cat and mouse. Something comes out, makes it easier. Researchers are releasing open source tools. We'll see a couple of those here shortly. Anybody have a reason, specifically around the 2022 timeframe, we'll say March, April-ish? Does anybody have an idea? Taxes, that's a good idea. When did the Uber breach happen? Around that time frame. And so you see that big spike up there, and then you just see it just continue to go up and up and up. This is those attackers targeting the push notifications, that MFA fatigue. So let's get into some demos. We're going to start early, so we're going to see the evolution of these attacks through these next 4 demos. Attack number 1, we're going to call this the adversary in the middle, or the MFA session writing bypass. So we got some videos up here. We got the scary hacker in the background with the black box. You're going to see some sweet green writing. It's going to look pretty legit here. And then this little window down here is actually the end user, right? So the end user receives a phishing email. It's legit. It's got a real email address. It's got a pretty sweet logo at the bottom, so it's got to be legit. No misspellings. We're going to click that link, and this user, here in a couple seconds, because they're probably on hotel Wi-Fi, so it's slow, is going to sign in. So this is taking you to, obviously, a phishing website, okay? We got our user that's going to log in and goes, oh, I need to get into this, so it's asking me to log in. I should log in. And so here in a second, I say this every time I give this presentation. I need to speed this video up, but as you see in the background, we have captured the user ID and password, but we're secure because there's multi-factor authentication. Well, what we did in the background that you didn't see was we accepted that Microsoft Authenticator yes or no push, and now the user's in. Okay? Here in a second, as we fade out, we're going to show what we captured. This is a free and open source utility. It's called Evil Jinx. Freely available on GitHub. It can be difficult to configure, but as the technology improves, these are becoming easier and easier. So what we have here is the session login, and this, most importantly, is what we call the session token, right? That's that cookie. Think Cookie Monsters, right? Nom nom, I'm kind of hungry now. The attacker's copying that, and here in a second, you'll see we're going to open up a web browser that does not have any logins in it. We're modifying the cookie in the browser. We're going to paste this in, and then we're going to refresh the page. And now we're into Adele's account. No multi-factor authentication required. So from a high level, I know the video can be hard to see. The attacker is going to send a phishing email to the user. That user is going to log into the phishing site through that man in the middle or adversary in the middle proxy. That proxy is going to intercept and relay the request to the service, right? We got our Office 365 there. Service is going to send that back to the proxy, which then in turn goes to the user to input or accept yes, no, if it was a one-time passcode or a text message they had to enter, or that RSA token that you have to type in. We then capture that, and then we relay it through. And now you have full access to the account. That was the first one that was made public, probably in around 2010 or so. So attack number 2, illicit application consent grant. Who likes to use that sign in with Microsoft button? Okay, so when you're going to a website and you click sign in with Microsoft or something to that nature, you're going to get a prompt that says you've authenticated. This application, lucid.app, wants access to your data, your emails, etc., etc., etc. That is an OAuth application, right? You authorize that. It uses some sneaky technical stuff on the back end to continue that and give it access. So you can do those sweet charts. That's what this looks like. So again, another free and open source tool. We've got an attacker in the background, and then we've got our unwitting user. Again, a phishing link. It's going to log in. You can tell they're secure. They must be using a password manager. They just pasted a really long password into that box. We're going to accept that. That's the multi-factor authentication push through an Android emulator. And this is your OAuth app. Now, if I could pause the video without screwing my slide deck up, I'd show you that that was full permission to everything. So make sure when you are using it, not that it's insecure, but make sure you're reading what you're giving it access to make sure. If it ever says full everything, just click no and reset your credentials. So what's happening in the background now that that user logged in is we're actually relaying that into OneDrive. And so if you look over here, we're actually navigating through our middle proxy that intercepted that in a nice visible web GUI, all of the data within the user's OneDrive. No multi-factor authentication required now that we're in. So looking at other files, we get the session token if we wanted to log in elsewhere or use that to pivot. User password list, that looks fun. Again, free and open source tools. We do this in a non-efficient manner from a demo purpose, but most of this is automated. All 4 of these that we'll see today has been pretty heavily automated at that point. So what does that actually look like outside the video? That attacker is going to create that malicious, what we call Azure registered application. This can be done in a couple ways. Microsoft allows you to create dev tenants with full licensing for 30 days. You just need an email address. So sometimes attackers will stand this up as a dev, they'll create that application, they'll sign it, and then they'll use that through their phishing campaign. One of the more common ones we see with incident response when we're seeing this is actually they've compromised a tenant at a different organization, and they build the application there because it's much more trustworthy. It's not new, it's harder to look at that intelligence, and then they'll use that as part of pivoting and getting into other organizations. That attacker sends that link, again, phishing, to the user. The user's going to authenticate to the attacker site, and it's going to authorize that. Again, here's what this is going to look like, and if you look close, for purposes, we named our app Risky App. It's never going to be that obvious. It might say unverified. That's a key there. But most importantly, this app would like to maintain access to your data, read all your contacts, sign in and out of your profile, read your email, send mail as you, and a bunch of other things. So probably not a good idea if that happens. The app's going to send the authorization code to the attacker. The attacker relays that back and asks for a brand new session token, most likely without an expiration tag or a timeout. And then they're going to use that token to access systems without an MFA prompt. One way we're still seeing this used in the wild, with the automation and the way the attackers are doing this, this is one of the ways they maintain persistence for business email compromise. It's harder to detect than adding a new MFA device, but it's all automated on the back end. Once that's there, it does this and it stores that session token, right? So attack 3, again, Uber breach. Is everybody familiar with that? Does everybody know how the attacker got into Uber? This is the exact way the attacker gets into Uber. MFA fatigue, MFA bombing, marketing, whiz bang, jazz, whatever you want to call it, it's pretty much the same here. So here, we've got a much more marketing approved video than the ones I put in there because it's got cool animations. We got Diego logging in here, and you got his phone he's got in his hand. Well, he logged in and he gets a prompt. I didn't try to sign in. All right, let's deny that. Well, let me send another one. No, that's not me. All right, I'll send another one back. No, all right. Man, it's 11 p.m. at night. Why is this thing happening? Must be that Outlook app on my phone. Maybe it's trying to re-authenticate. I'm just going to click yes because I can't wake my wife up laying next to me because this thing's buzzing, right? Now the user's in. So what that looks like, that would obviously be automated. The attacker's not going to sit there and just wait and click. They're going to send them in a much more rapid succession. The attacker's going to authenticate to the site with the compromised credentials. We talked about password problems earlier, right? A lot of the times, whether we're doing penetration testing or we're responding to incidents, the first place we go is the dark web. We go search for the credentials online if they're there. There's also password spraying attacks, right? Who uses seasons, months, or some other common things for part of their password, right? Fall 2024 exclamation point with a capital F. I bet somebody in here has that password. So we're going to use those compromised credentials. In this case, it doesn't require a phish. We're going to authenticate. The user is going to receive a push mobile device to their mobile device. It's going to look like that if you're using Microsoft. And I don't hate Microsoft. They're just easy to pick on, so it's really good for demo purposes. The user is going to deny that sign-in approval. The attacker is going to send another MFA request, and another, and another. And finally, that guy or gal is going to just say yes to get that off their prompt. The user approves it due to fatigue, marketing, and then the attacker is going to log in with MFA persistence. Attack number 4. This is the no VNC bypass. This is one of the more recent ones. And this one's a little unique. Although you do still have to send a phishing email or entice somebody to click a link through a new vulnerability of some sort. This is unique because you're not actually interacting with a phishing website. You are logging in to the real Office365.com with how this attack works, and we'll walk through that. Does everybody know what VNC is? Similar to remote desktop, just a little different. Allows you remote access. You can do stuff to machines once it's installed. So this is what this looks like. Starbucks e-gift cards. Funny story about that. I'll tell you after this video goes because it's pretty quick. The user's going to log in because they want that free Starbucks gift card. Although that's their inbox, and I blurred the URL out because this was our production instance. This user is logging in to the real Microsoft.com. So when they click the link, and now we're in. Now we got the scary black hacker boxes. Put your black hoodie on and go to your mom's basement. There's your session token again. We've captured that. Now I'll explain the uniqueness here in a second. We got the attacker going back in. They're going to hit next. We're going to inject the cookie. And as long as this is the same video, it's going to log in. So 2 things on that while we're walking through that. We do part of penetration testing as part of our service offering for customers, right? Be those hired hackers. That Starbucks gift card email, our HR department actually sent out internally as a legitimate thank you item. Within 3 hours, my red team moved that into a phishing campaign, and we ran it for 6 months straight, and there was an 80% hit rate on it. So it's still kind of minute, right? So again, that attacker is going to send a phishing email to the user. The user is going to log into what we call the attacker-controlled system. So no VNC, that phishing link doesn't go to a web page where there's a login form. It goes to a VNC session, a remotely hosted VNC session. It passes a username and password and the URL parameter, and it logs you into the machine. And if the attacker configures this correctly, it's actually a Firefox web browser in the background running in kiosk mode. You are literally logging on to an attacker-controlled machine. Linux, kiosk mode with the web browser. You log in, it's hard to find that, you're trained to look for URLs and things like that. Valid session attacker is stored in the web browser. Mozilla uses SQLite DBs still. It's accessible locally. That's why you don't want to save your passwords. Do you want to save this password, yes or no? Store your session. You always click yes. You don't want to have to authenticate. That stores that in a locally accessible database. So since you're on the attacker-controlled machine, when we pulled up that hacker box, the command prompt in the background, all we did was run a Python script that dumped the session out of the local DB. No fancy whiz-bang stuff. Just log into my machine. Valid sessions stored. We use that token to authenticate as the user. This one is difficult to detect. This one is probably one of the most prevalent ones we see today. There have been recent open source tools, one specifically released at Black Hat and DEF CON this year, that automates this entire process. So what are some quick wins, right? For session token stealing, you want to leverage those conditional access policies in Azure as you have them. Most license levels for Microsoft are going to have this. Restrict access based on multiple factors, right? If it's not Azure AD joined, if it's something else, prompt that. If you're fortunate enough to be able to afford Azure AD Premium Level 2 without an E5 license or with an E5 license, they have shipped a conditional access policy that will detect a login with the same session token from a different location, and they'll block that. They'll disable all the sessions. But you have to pay for that, right? Paygate security, it's a problem. Leverage robust session timeouts to minimize that persistence. If it is going to happen, limit your blast radius. And most important, leverage behavioral detection technologies to prompt for additional authentication or invalidate that duplicate session. We call that step-up authentication as well. If you conduct a high-risk transaction or you're logging in and something looks different, hey, you usually log in with Mozilla Firefox from the US of A, and now you're logging in from a Linux host running a Mozilla Firefox from, Canada. Probably should have that behavioral detection in there. So what about that illicit consent grant? By default, all users in your Azure AD tenant have the ability to add these applications. Turn it off. You want to find a quick way to stop shadow IT? Just don't give them access to add applications. Right? You're going to want to control that. Wrap that back into your identity plane. Require admin approval for authorizing those. There are some times you need to do it, right? But make sure it runs through your change control process. Approve that, document it, and then monitor it. Again, you're going to see a theme in the next slide too. Continuously monitor your environment for app consents. Microsoft has a free PowerShell script for any level where you can run this, and if you schedule it, it will look for new application consent grants in your network. It's going to be a pain the first time because you're going to be like, holy smokes, I have 37 users in my tenant. Why do I have 3,000 OAuth applications? Sign in with Microsoft. Let's go. What about MFA fatigue? Who still, for MFA, relies on a yes and a no only? Couple people, okay. One, it's a rapid push, so limit the number of simultaneously push attempts that come out of your system. Two, enable MFA number matching. If you're a duo, it's going to be verified push, something similar. And what that is you have to actually type a number in. It's going to prompt you. You have to type that number in on your phone. 87. If you put 87 in on the phone, it's yes. And although if you did it and you hit yes, you'd still give access to the attacker, it's hacking your brain. You can't just close your eyes and say, all right, whatever, I'm not looking at this. You physically have to be looking at a number. So if you get prompted for this and you're not staring at your web browser with the number, chances are something happens. Call IT, call your SOC. Hey, my credentials are compromised. I don't know how. We need to reset it. Go hunt that environment. Configure detection rules, right? If we can detect it, if there's an artifact, we can write a logic rule to do this. Detection controls are my favorite control in any environment. You're always going to be able to bypass something. We talk Tom and Jerry, cat and mouse, right? There's always ways to detect that and improve your detection rules so you have a fighting chance rather than they gained access to the CEO's email. They sent 1,000 outbound emails with malicious links on them, and now I've got a huge blast radius to deal with from a reputational and a security standpoint. Train your users. If you see this or this is happening all the time, call me. It's not normal. Just let me know. It's okay. For the no VNC bypass, again, very similar to some others, we're going to have to leverage those conditional access policies as well as the behavioral detection. That's very difficult to detect. There are ways where you can write some policies that look for specific user agents that are coming across because they're usually specific. That can help. But again, I don't want to harp on training too much, but there's a lot of that there. So what's next? I know you think MFA is not affected. Layered security, Donkey and Shrek with the onion and the 7 layers. It is still effective. Please don't go home today or Monday when you get back to work and tell everybody or do it yourself by disabling MFA. Your users might love you, but that fall 2024 exclamation point password is now much easier to get in with. Right? There's no prompt. Enable number matching, I believe as of today, a few months ago, that's Microsoft's default option if it wasn't turned on before. So they're catching up. Implement phishing resistant MFA. Who has YubiKeys? How many of you use those in your corporate environment? How many of you use those in a corporate required environment and it's not just your YubiKey that you use? Yeah, okay. Technology's getting better. YubiKeys use the FIDO protocol on the back end, and instead of just relying on a yes, no, here's a number, here's an OTP code, most phishing sites are not hosted on the legitimate website. If they are, we got a bigger problem. And so these new technologies are actually pairing and binding domain names when you register them the first time, where you shouldn't be clicking a link to register, you go to the real website. They're binding that domain with a public-private key pair. So if you tap that YubiKey and you're on Office 365 that has a 1 instead of an I, it's not going to work. It's just not going to send it. So your MFA's broke. Can't auth. They might have your credentials, but they can't get into your account. Go passwordless. This is the new sexy buzzword. Every identity provider out there has increased their margins by at least 25% because they say they do passwordless now. It's the nature of the beast. That's getting much easier to implement, and I think that is where we're going, is more passwordless rather than phishing resistant tokens. In some very high secure DoD environments, you're going to have a requirement for those types of tokens. But passwordless is getting used by you every single day, whether you know it or not. Your iPhones, your Androids, you use your thumbprint or your Face ID. Those use passkeys on the back end. You have to type your credentials in once. Do you want to save it and use passkeys? The answer is yes. You don't have to type your password in anymore. You got to use your face. Got to use your thumbprint. I had somebody try to use their toe one time. It's like, what are you doing? Leverage risk-based authentication. We have to monitor identity usage. We have to know if a user logs in and they're an iPhone user that's registered, but they just registered an Android device or authed an MFA through an Android device. That's different. I should look into that. Hey, did you get a new phone? I mean, I don't advise you go from iPhone to Android. That's like going backwards 10 years. But did you? Yeah, I lost it. This was the only thing they had. Or no, I don't use an Android phone. Oh, all right. Well, we're going to delete those devices and reset your credentials. And yeah, talk to me about what you clicked on in the last 32 minutes. And then again, continue to tune detection rules. It's difficult to detect, but they're going to bypass those prevention controls. So as we work through, as we continue to mature, as we add those layers, look for things to detect. For example, business email compromise is almost completely automated at this point once the credential goes in. The credential gets sprayed in, they auth, they go through MFA, the attacker auths, pulls the session token, re-injects it back in, adds another MFA device or an OAuth app, and then they add a mailbox forwarding rule. If those things happen within 2 minutes of each other, that's a 99.99999% probability of a compromised account. Detect that. Although that's detecting BEC, you're still detecting the MFA, the bypass. You know that, that's there. And that's what I have today. Do we have any questions? Yes, right here. Yeah, great question. So the question was, in the no VNC bypass attack, what's the tell? How can you train users to potentially spot this? Um, is it a link? Is the link different? And the answer to that is yes. So in the email, that link will not say login.microsoft.com. That link will be the phishing domain that passes the VNC through. But when you're staring at the screen in the web browser, you won't see that because that's taking control of the piece and it's in kiosk mode. So you'll be logging in directly to login.office.com or whatever it is. Yeah, so a follow up is kind of to that question was the training, like what's the general tact on how to help with that? And yes, you can copy it out in your browser. That is becoming less and less effective. Hovering is still a thing, right? However, because of Microsoft Safe Links and all of these other ones that rewrite that URL that comes through, and so when you hover it, you got 3,000 characters before you see the real domain. It's difficult. So normal training, if you're not expecting that email, if it looks nefarious or malicious, probably is err on the side of caution. Um, coach communication with that. I don't want to say it's the same stuff from 12 years ago when we started to have to train, but it's pretty gosh darn close. That's why, again, I'm a fan of detection rules. Users are smart. They're also vulnerable. They also have a job to do. And so the more things we can add into that you're in control of to find some of these other things, the different login scenarios, the different types of devices and some stuff like that, the better off we are by working together. I will never blame a user for a breach. We could do better somewhere else. Whether they click the link, they put their credentials in, and they had local admin, whose fault is that? IT's. You have local admin. Let's do some basic stuff, right? So, great questions. What else? Yes. Yes, we are. That is the new NIST standard or newish NIST standard that came out, what, 2.5, 3 years ago? We are seeing movement on that. We see more movement on that for high privileged accounts. Um, but again, if you can't type your passphrase in and you copy it out of your password vault and you submit it in the form, we're back to square one. I like longer passwords. I came from the financial services industry a long, long time ago. You had to change passwords every 30 to 90 days there. Users hated that. You also have to weigh the risk of long passwords and long extension time with what we like to call persistence. So if you have high probability of detecting compromised credentials, you can go to longer stuff. But you do have to weigh the risk on if a user gets in 60 days after that person changed their password and you don't have other controls in to detect it, you're giving them long time persistence. Just some food for thought. Great questions. Anybody else? Yeah. What role does zero trust play in on this? Zero trust is an aspirational goal. I cannot name nor have I seen any organization implement zero trust to the standard that it's documented. So, get off my soapbox a little bit because I hear zero trust 40 billion times a day and we go back to the same thing. Let's talk zero trust real quick and then I'll wrap it up into this. We go away from the castle and moat mentality, right? Get everything into the cloud, get everything into the cloud. Get the VPN away. We're doing the same thing in the cloud. You migrate everything to the cloud, now you're doing the same thing. Because zero trust, if you can do it right and start moving the needle, is an identity-first problem. It's identity. It's not about network segmentation. They're going to tell you it is. If you cannot do identity right, you have no chance at getting zero trust. Because now we get into the backbone, right? So zero trust. The best zero trust implementations I've seen are identity-based. We just talked about that, but still rely on the same thing. It goes back to the old school castle and moat mentality. Once the user authenticates and validates multi-factor, however, they're inherently trusted. That is direct opposite of what zero trust is. So these MFA bypass attacks are pretty prevalent in a zero trust environment. Zero trust is what we call a framework. It's not a technology. It's not a thing. NIST is a framework. Great questions. I don't know how we are on time, but nobody's came in to yell at me yet. We got some more time. Any other questions? Yeah. Mm-hmm. Yeah, great question. The question was, with the role of AI, what have we seen benefit from the AI into the behavioral detection of this and or that? So I'm going to take this two parts. One, the behavioral and detection side is getting better. You've got those technologies built in that are looking at the user's anomalies and their patterns, right? It's creating the baseline, and then if there's a deviation, it's going to let you know about it. So a lot of identity providers are doing well with some of that step-up authentication, that behavior risk. They're correlating that data. All of that new technology. If you buy a product today that does not have the AI or ML on their website, let me know who that is because I haven't found one yet. It's baked in, and so as that continues to go, right? We've got the training, you've got the model aspect of it, but we're also seeing AI used on the offensive side. And so it's making those generative decisions based off X, Y, and Z, and it's no MFA, go here, MFA, send this, or retarget the user. So, great questions. Anything else? Oh, we got one in the back. Do I have tips for setting up the session control in Azure for best practices? If I brought my sysadmin hat, my cloud admin hat, I probably would. We can talk a little more offline about that. Leverage natively what Microsoft has if you're in Azure AD. Start there. Don't start from scratch because you will miss something or you'll exclude something. Something I didn't talk about a lot, but most conditional access policies have an exclusion in them. And they're frequently mobile devices. So when we're doing testing, we just change our user agent to be an iPhone and an Android, and we're not even prompted with MFA. Or the corporate network, the NAT address, is excluded. So anybody that logs in from inside a trusted location doesn't have to use MFA, including admins. So Microsoft does have some good ones, right? You need to look at location, session token, and then you can do your actions. But their low code wizard, right? Low code's a thing. Their low code wizard has some steps that will allow you to work on that. Now again, you're not going to get automatic blocking unless you have P2 at this point. I'm hoping that gets enough Paygate security blowback from the community that Microsoft just releases that as well, like they did their additional logs after the storm attack. But all right, got time for one more if there is one. If not, then everybody can get out of here and go get a drink or some food and plan the rest of the day. If you don't want to connect to me, that's my LinkedIn QR code. It is not malicious. I will not capture your MFA token, but please connect. Thank you very much.